TPH is a complex mixture of chemicals. So what is the best way to look for TPH in the environment? In this video, we will discuss common analytical approaches for TPH and how your selection of analytical method can impact your site characterization. As we start thinking about choosing analytical methods to use at a site, there are a few key things to keep in mind about TPH. TPH is a complex mixture that can contain thousands of compounds. So when you see that TPH data point on a lab report or on a data table, what does it represent? There are a few key points to keep in mind when you're looking at TPH data. First, unlike a single chemical where the concentration will be fairly predictable across different methods, TPH is actually defined by the analytical method used to measure it. In other words, depending on what method is used, the analytical result can vary significantly. Second, that TPH result represents an approximate concentration of the total organic compounds in the sample. Lastly, because the result is representing the total organic compounds in a sample, the term total petroleum hydrocarbons is a bit of a misnomer, since the resulting data isn't necessarily total, not necessarily petroleum, and not necessarily all hydrocarbons. TPH is a method-defined parameter, and since no method can do everything, you should consider the following items in order to select the most appropriate method. What are your data quality objectives and application? Are you looking to delineate the area of contamination or perform a risk assessment? These two objectives could require different analytical methods. Also, certain methods should not be applied to every medium. Since TPH is a method-defined parameter, results should always be reviewed in the appropriate context. Looking at the chart on the right side of the slide, you can see an example of a number of non-petroleum materials that were analyzed by 4 different TPH methods with widely varying results. Given the potential variability in results, methods should be selected to fit the project goals and be cost-effective. Next, we will talk about specific analytical methods and approaches that can be used to tailor your data. Let's start with a commonly used technique to remove method interferences. EPA method 3630C describes the use of silica gel to remove non-hydrocarbons and potentially naturally occurring compounds from the analysis. The silica gel cleanup results in a hydrocarbon-only sample that can then be analyzed for bulk TPH. This results in hydrocarbon-only TPH data. This silica gel shown in the column on the right is a fine-grained version of the material that is found in various new items, such as shoes and suitcases, and is used to separate the hydrocarbons from the non-hydrocarbons. There are a variety of cleanup options, but the column cleanup is the most effective at removal of non-hydrocarbons. One thing to be aware of from a quality control standpoint, a lab surrogate should be used to ensure the silica gel efficiently retains the non-hydrocarbons. When would you want to use a silica gel cleanup method? Silica gel cleanup is part of making sure you have your site conceptual model right. Silica gel cleanup is frequently used in the determination of extent of hydrocarbon impact versus naturally occurring organics or polar metabolites, and can therefore help better understand where to perform active remediation. One thing to be aware of with silica gel cleanup is that it will result in some loss of volatile phase compounds. Consequently, it's not considered appropriate for volatile phase or air phase samples. Currently, there is no cleanup method for volatile or air phase samples. Fractionation is an analytical method where silica gel is not used to clean up the sample, but to separate the sample into aliphatics and aromatics to help answer the questions on the right. Fractionation methods can provide more detailed information that's useful for risk assessment or fate and transport purposes. Fractionation can be applied to all matrices, NAPL, soil, water, gas, but it is not typically necessary or recommended for water because years ago there were a number of studies performed that allowed us to easily predict the hydrocarbons in the water phase. Caution should also be used if fractionating soil gas samples, and an alternative fractionation method that does not require the use of silica gel for volatiles should be considered. Once separated, the aromatic and aliphatic fractions are then injected into a GC to obtain information on equivalent carbon ranges. There are different fractionation methods available, and each method reports slightly different fraction ranges. So it's important to consult your risk assessor and make sure you're selecting your fractionation method in consideration of the regulatory agency you're working under. Although the fractionation methods can provide detailed information, they do cost more than bulk TPH. They will remove non-hydrocarbons from the analysis, and there will be raised reporting limits. With all of the different options out there, how should you choose which TPH method to use at your site? Here is a brief summary of TPH methods for water and soil matrices. Bulk TPH methods, such as EPA method 8015, EPA method 8260, or Texas 1005, are methods that give the kind of total TPH or GRO-DRO results people may be used to seeing. These methods are best used for initial site assessment, determination of the overall extent of impacts, or quantification of total extractable organics. However, be aware that these methods may over-report the extent of actual petroleum hydrocarbons, and these results have limited usability in risk assessment. It is difficult to evaluate risk for as varied a mixture as TPH. Many agencies have turned to methods that separate the sample into fractions. In order to better understand fate and transport or risk, fractionation methods are frequently applied to a small percentage of the samples to better understand hot areas or areas of high uncertainty. These methods can be used to define extent, but they have higher costs, so are typically used more judiciously than bulk TPH analyses. Typical methods such as Texas 1006, Massachusetts VPH-EPH, or Washington Department of Ecology methods should be used. If you are only interested in hydrocarbons and not total extractable organics or metabolites, EPA method 3630C, followed by a bulk TPH method, should be used. If you are still unsure of what TPH method to use, I encourage you to talk to the chemists at the lab and your risk assessor. In summary, just remember that TPH is a method-defined parameter, so method selection is critical in getting the best results to support your project objectives. The last message I want you to remember is that not all TPH data is the same and comparable. Different methods will give different results, and different labs may give different results by the same method, given potential differences in extraction solvents, calibration standards, and other items. TPH data is complicated because of the number of chemicals included in the results. So look closely at your data. Don't take things that don't make sense at face value. When in doubt, dig a little deeper. If you are interested in obtaining additional information on PVI, LNAPL, or TPH, please visit the following ITRC websites, which contain links to both guidance documents and fact sheets.